video is on the rules of differentiation of vectors. If we have three vectors u, v, and w, differentiable with respect to t, and a scalar phi also differentiable with respect to t, then the following rules of differentiation hold. Number 1, the derivative of the sum of two vectors u and v is equal to the sum of their individual derivatives. That is, d dt of u plus v is equal to du dt plus dv dt. Number 2, the derivative of the dot product of two vectors is equal to the dot product of the first vector and the derivative of the second vector plus the dot product of the second vector and the derivative of the first vector. That is, d dt of u dot v is equal to u dot dv dt plus du dt dot v. This is also called the product rule. The third one is the derivative of the cross product of two vectors is equal to the cross product of the first vector and the derivative of the second vector plus the cross product of the second vector and the derivative of the first vector. That is, d dt of u cross v is equal to u cross dv dt plus v cross du dt. Number 4, the derivative of the product of a scalar and a vector is equal to the product of the scalar and the derivative of the vector plus the product of the derivative of the scalar and the vector. That is, d dt of phi u is equal to phi du dt plus the phi dt u. Number 5 involves three vectors u, v, and w. Let's look at it. d dt of u dot v cross w is equal to u dot v cross the w dt plus u dot dv dt cross w plus du dt dot v cross w. Number 6, d dt of u cross v cross w is equal to u cross v cross the w dt plus u cross dv dt cross w plus du dt cross v cross w. Now we are going to solve a few examples that will involve applying these rules. Example: if u is equal to t squared I minus tj plus 2t plus 1k and v is equal to 2t minus 3I plus j minus tk, find I d dt of u dot v, I d dt of u cross v, I d dt of absolute value of u plus v at t equal to 1. Solution. The first one is to find the derivative of u dot v. To find that, let's find u dot v first. U dot v is the dot product of the two vectors u and v. If you want to take the dot product of these two vectors, you multiply the two vectors component-wise. That is, you multiply the I component of u by the I component of v, and multiply the j component of u by the j component of v, and lastly you multiply the k component of u by the k component of v. If you do that, you're going to have 2t cubed minus 5t squared minus 2t. Then, since we have gotten the dot product, we will now take the derivative of the dot product. The derivative of the dot product gives us 6t squared minus 10t minus 2. Or using the product rule, we can solve this. The product rule is d dt of u dot v is equal to u dot dv dt plus du dt dot v. Here we will have to find the derivative of v and also find the derivative of u. If we find the two derivatives, then we'll now take the product u dot dv dt and the product du dt dot v. Then add the two products together. If we do that, we will still arrive at the same 6t squared minus 10t minus 2. Number II is to find the derivative of u cross v. The derivative of u cross v can be gotten by the rule d dt of u cross v equal to u cross dv dt plus du dt cross v. Or we can find u cross v and then find its derivative. To find u cross v, we simply need to find the determinant of a 3 by 3 matrix that is formed with the components of u and v in the ijk direction. The components of that determinant will be, on the first row we have I, j, k, and on the second row we have t squared minus t, 2t plus 1, 2t minus 3, 1, and minus t. If we find this determinant, we will have t squared minus 2t minus 1 times I plus t cubed plus 4t squared minus 4t minus 3 times j plus 3t squared minus 3t times k. That is the determinant, which gives us u cross v. Now, to find the derivative of u cross v, we take the derivative of this value. If we take the derivative, we will have d dt of u cross v is equal to 2t minus 2 times I plus 3t squared plus 8t minus 4j plus 6t minus 3k. That is the derivative of u cross v. Number III is to find the derivative of the absolute value of u plus v at t equal to 1. The first thing to do is to find u plus v. U plus v is equal to t squared plus 2t minus 3I plus 1 minus tj plus t plus 1k. Next is to find the absolute value of u plus v. The absolute value of u plus v is equal to the square root of t squared plus 2t minus 3 raised to power 2 plus 1 minus t raised to power 2 plus t plus 1 raised to power 2. Now we have to find the value of each of the terms inside the square root sign. The first term there t squared plus 2t minus 3 raised to power 2. If we expand it, we will have t to power 4 plus 4t cubed minus 2t squared minus 12t plus 9. And the second term, 1 minus t to power 2 is equal to 1 minus 2t plus t squared, while the third term, 1 plus t raised to power 2, is equal to 1 plus 2t plus t squared. Since we have gotten the values of all the terms in the square root sign, if we simplify them, we will arrive at t to power 4 plus 4t cubed minus 12t plus 11. That means the absolute value of u plus v is equal to square root of t to power 4 plus 4t cubed minus 12t plus 11. This can equally be written as t to power 4 plus 4t cubed minus 12t plus 11 raised to power 1 over 2. Next is to find the derivative of the absolute value of u plus v. Since we already have an expression for the absolute value of u plus v, if we take its derivative, we will get 1 over 2 multiplied by t raised to power 4 plus 4t raised to power 3 minus 12t plus 11 raised to power minus half multiplied by 4t to power 3 plus 12t squared minus 12. And then the last thing to do is to find the value of this derivative at t equal to 1. This means that we have to replace t with 1. Anywhere we find t, we will replace it with 1 and then simplify. If we do that, we are going to arrive at 1. So, d dt of u plus v at t equal to 1 is equal to 1. This is the end of this video. If this video has been helpful or you have learned one or two things from it, please click the like button. And if you have any questions, feel free to leave them in the comments section. Don't forget to subscribe to this channel. Thank you for watching.